Welcome to a very important episode of the It Depends podcast. The reason I'm saying it's important is because we are now reaching a stage where agentic architecture is starting to move beyond hype into reality. At the same time, we're seeing there's a lot of backlash. For example, we see that Microsoft is asking its vast army of developers to stop using Anthropic's Cloud Code and instead use GitHub Copilot. We're also seeing from an enterprise point of view how Uber has exhausted the entire year's budget for tokens in the first 3 to 4 months of 2026. So, to understand what lessons have we learned, where are we going, how should enterprises strategically plan for agents, I am so happy to have Rajesh Parikh join us all the way from Bangalore. He and I have collaborated extensively in our yearly predictions, in a number of podcasts we have done. So, Rajesh, you are a hands on practitioner. You are seeing this from the front row seat. So, I'm so happy to have you join this podcast.
Thanks, Sanjeev. Back to be on your podcast again.
Amazing. All right. So, walk us through what are some of the burning questions that we will be talking about today?
Yeah, so essentially what we're going through today is just take a step back and look at how did we fare. And by the way, this whole conversation is focused on enterprise
Hmm.
and not, let's say, an individual professional coding agent or a professional coder. Or, for example, it's not focused on, in some ways, the individual personal agents and things like that. So we're going to focus on lessons learned primarily from the enterprise standpoint, both in the last 12 months and prior to that. What's going right and what can be done better? And have we learned anything? Are we doing anything better? That's part one of what we want to discuss. We also want to talk about this framing of agents and the agent architectures, because strategically it's also linked to what pieces of these agents that enterprises owns itself or rents, or essentially it's a builder versus buy. What are you
Hmm.
building? What are you buying? Where do you have the vendor lock, so on and so forth, right? That's the second piece. The third is, of course, what are the challenges that we're seeing today in operationalizing agents? And there are various approaches to doing that today. But essentially, there are things that are working out well. For example, coding, some bit customer support, personal agent, maybe general agents. But there are a lot of the agents which enterprises want, which are more around, let's say, the business process automation or process automation in general. There you see some challenges to go from demo to production. So that's the one. Then we basically segue into this topic of agent harness versus a term that at least I am in. We've been working forwardly in our labs, which is the, I call it A2A. We will talk about it as to how this can bring independence from an enterprise standpoint, and how can they own their own harness. The last two pieces are more forward looking, which is around, there's a lot of talk around self-learning agents. The the real thing here is today the way we are going to build agents is we have a model which has been frozen in its capabilities, and then
Hmm.
we're building things around it. And at some point, this whole system architecture would move into agents which will learn and improve by themselves,
Yeah.
right? So that also means that the stack that we're working today with and what we will be working, let's say, in the next 1 to 3 years or 3 to 5 years could potentially look different,
Yeah.
right? So how do we reduce the gap and where we stand today versus where we are heading?
Yeah. By the way, my favorite in all of this is harness engineering. So I'm really curious, want to dig deep into that. And reinforcement learning is such a hot topic. So many important things that we are going to talk about today. Let's start with lessons learned. So you mentioned like we have the whole data era to learn from. So what's the gist of this, and how should we think about what have we learned from the past?
There are many things that we've learned. One, of course, is that a lot of investments have gone into the data infra over, let's say, a long decade of 2020s and half of the decade, this particular decade of 30s. Uh, uh, and essentially what we're seeing is that enterprises haven't really taken advantage of much beyond the dashboards. Let's call it BI dashboards,
Yeah.
right? Effectively, sort of a command control for what has happened in the business.
Hmm.
But that can only go so far, which is that you know what is happening, but your business dynamics are changing much more rapidly and much more faster, which means without having a pulse of how should my future look like or what's going to happen, if you're not going to get those use cases done, then there is not much value of all this
Correct.
investment, right? That is one part of the story. The second
Mm.
part is, of course, a lot of dreams were sold around fragmentation, lots of technologies. A lot of enterprises initially started with a fragmented data tool chain and now on a consolidated, unified data platform. All of that done, and yet the usable data products beyond BI are far and few, right? So that's the second learning, which is that the real value did not come in because we didn't have real data products. Now, obviously, what that means is your data strategy was tied to the vendor strategy, vendor's data strategy, vendor platform strategy, and not necessarily what products you really wanted.
Correct.
So that is essentially what we've learned, that if you've not architected well what you really want, what strategy you want to go after, the tools and platforms you pick are really going to drive what you eventually end up with.
Hmm.
Right. So having a good, clear idea about what is that I really want as an enterprise over, let's say, 1 to 4 years, what products, AI products do I really want,
Hmm.
uh, is really going to be important as you adopt many of these infrastructure platforms, models, all of that today. Right. So what we've started seeing in over the last 12 months is, again, we have fragmented tool chains all over the place. There's memory, there's MCP, there's harness. We've started seeing harnesses getting bundled with the model platforms themselves. And we've seen like lang chains of the world. The lang chain itself now proposes deep agents, for example, the second framework, right? So if you're an enterprise, you probably moved around many of these frameworks over the last 8 to 9 months or 8 to 10 months, essentially. And then the ideas have kept moving, right? So let's say if you're doing 10 use cases, you likely ended up with 10 different harnesses potentially
Yeah.
uh,
Very
from different
similar
vendors.
to this modern data stack where we had so many different tools to complete the pipeline. So,
Yes.
yeah.
Yes. So, and then there is still something missing. There are deficits. There are new versions. So, in an ecosystem that's rapidly evolving, the ideas, the shelf life of any idea or any software is shrinking,
Hmm.
which essentially means how do you cope with the shrinking shelf life of, let's say, a product or a tool that you've integrated with, and still be able to smoothly migrate out when there is a new version of the same thing, right? This is very extremely challenging today. You essentially are going to end up, let's say, building tens of agents with an harness A today. And let's say if the harness A is not something that looks
Hmm.
futuristic, it's 3 months, you will end up redoing all of those tens on a different harness,
That's
right?
a
So the
very scary
migration,
thought.
yeah,
You change the harness and you have to redo everything from scratch.
yeah. And I think this is a practical experience. Many of the people, we ourselves have sort of flipped our harness like at least 2 times now,
I
two or
see.
three times. That is also because we have control. We build our own harness. But let's say you're not building your own harness,
Yeah.
then you end up in a situation where you have tens of them,
Yeah.
right?
In fact,
So yeah,
no, go ahead. Yeah.
now, having experienced it is where this particular thought process comes, that if you're not owning your harness, potentially you have a much stronger and tighter vendor lock. For all your agents, and migration could potentially become challenging if for whatever reason you really want to not be with the same vendor.
It reminded me of Sam Altman recently said The model is not the product.
Yeah,
It's a means to the end. And that's interesting because OpenAI was built as a company to develop foundation models. And he's saying model is not the product, it's the harness. And we'll talk more about what exactly a harness is, but it's everything around it is what
yeah,
the product is.
yeah, yeah. So if you actually look at how, let's say, if you were to just open up, let's say, any agent stack, right?
Yeah,
It basically has these four pieces, if you want to call it that, where the base layer is the model.
yeah.
Then there is all the scaffolding around the model, which we call
Hmm,
harness.
hmm,
On top of this harness, you write your own skills, you bring in your own context, all of
hmm,
that. So these skills, this context is very specific to the agent that you're building.
hmm,
And then finally, there is a UI layer or what we call the interface layer,
hmm.
right? So any agent that you look at would basically have these four components to it.
So you got the model, you got the harness, you got the context, and then you have the interface.
Context, tools, skills, all of that
Yes, school,
is very
correct.
specific to
Yeah,
that particular.
yeah.
And then you
So
have the
yeah.
interface.
So moving on. So how has things changed in the last 12 months?
Yeah, so I think the first point we just discussed that there is a good amount of churn. Let's say you started with A harness, you moved to B, for example, you started with Crew AI, and then you moved to LangChain, and then you moved to Deep Agent, and so on and so forth.
Yeah.
Right. So that's one kind of a churn. The second churn is on the model side, which is that the model leaderships have also kept changing
Hmm.
over time. Right? And which means that, let's say you were using GPTs and then you moved to Claude, and now there are a lot of attractive options which are much cheaper in the OSS world served via third-party APIs. So you have that, right? So if you look at both the bottom layers that we discussed, both are churning, essentially moving around, moving
Hmm.
on, right? The
Correct.
other piece that's changing essentially is how we think about the agent. We started by thinking about agents as workflows on top of, let's say, a model,
Hmm.
right? Statically stitched via line graphs, so on and so forth. And now we're saying that those are just agentic workflows. They're not agents, and agents need to be far more autonomous. So
Yeah.
we started getting this thing called a skill layer,
Hmm.
which essentially would bind all your tools, your workflows, which are specified in natural language, and let the agent decide which skill to call uh, based on the user task, right? So that was the next phase that we entered. And as we go further, there's going to be, let's say, even more ideas. For example, just yesterday, I think Anthropic launched something called workflows or chains, essentially trying to suggest that you could basically, the agent itself could dynamically build its own workflow and parallelize it, essentially. Right? So let's say you have one agent which is coding, another agent which is simultaneously writing test code, test planning and code, all of that. And there's a third agent which is probably just writing the documentation. Right? So all of that itself could be chained by the master agent itself in some ways, right? And
Yeah.
parallelized. So there are more ideas that are coming.
So
Um,
talking about ideas, I find it so interesting how Anthropic comes up with something, the whole world jumps on it. They came up with
yeah,
MCP, and then for a time, I thought they weren't even that hot about MCP as they went into
yeah,
sandboxes. But then they came up with skills. Everybody jumped in skills. Then they said skills are just natural language markdown files. And ooh, everybody was like, markdown files. That became the hottest thing. And then I saw a few days ago that Anthropic said that markdown is not a very easily readable uh, format. So we are moving to HTML. So now they're focusing on writing skills in HTML because then you can have tables and frames and you can have headings, and so basically so we are back to HTML is my point. So
yeah. No, so I think so all of this is because if you look at the models
yeah,
themselves, how they are trained,
yeah,
right? If you look at the model itself as a stack,
yeah,
models have largely three layers, what we call the pre-training, the mid-training, and the post-training,
hmm,
right? The pre-training is pretty much about next token prediction, the transform
correct,
architecture, all of that.
yeah,
Mid training essentially has supervised fine tuning and some bit of RL. And then there is post training, which is largely RL today,
Hmm.
right? What it essentially, and these, so which means that the final outcome that you see from these models is largely how well they are aligned in the post training, right? So if you're
Yeah.
seeing something, if you like something about these models, they've been post trained on a large number of tasks,
Hmm.
uh, coding tasks, browser use tasks, all of that, right? So that's been the journey. We've moved from sort of pre-training to SFT
Yeah.
to now training for agentic tasks, basically the real world tasks, right?
Yeah.
So it wasn't enough to have a chat model sound intelligent. You actually want them to do something, right? So
Yeah.
over the year, what has happened is these models have gotten a lot better on instruction following, on tool calling, these kind of agentic capabilities.
Hmm.
What is still an issue though is if let's say you are sort of having a task which is out of the distribution of the task that the models were trained on. Let's say you're doing something which is not a coding agent or let's say not
Yeah.
something that these models have been trained on. Your experience does not align as well with, let's say, if you're actually building a coding agent, right? And that simply is a difference of the task distribution that these models have learned, right?
Yeah.
So that's one part of the story, which is that can you really get these generalized models to get you beyond, let's say, six? And by the way, my belief is that given the amount of number of environments these companies are collecting and sourcing, maybe they'll get better at all the tasks by the end of these years, by the end
Yeah,
of this year.
businesses took Cloud Code and they started using Cloud Code for all kinds of their business process automation or ideas, So it was meant for coding, but it was being used, and hence they then finally came out with Cloud Cowork.
Yeah, but even today there are many gaps. For
Yeah.
example, we just about started talking long multi-turn sort of
Yeah.
complicated tasks which
Let's
can
go
run
to the
for hours.
next slide because now
Yeah,
we're talking about the future, what's
yeah,
happening, right? So, okay, go
yeah.
ahead. Yeah. Yeah.
So the point, before we get to this slide, there's one point that we didn't cover,
Hmm.
which is that as this leadership is changing, there's another piece, which is that the OSSs
Yeah.
are closing the gap with the frontier
Yeah.
models,
So open source.
uh,
Yeah. Yeah.
open source models, and they
Yeah.
have gotten really, really good with many of the things that frontier model can do.
Yeah.
One of the trade-offs that, and this trade-off is real because the difference in cost of, let's say, a workhorse model that you have from the OSS versus, let's say, a frontier model like,
Yeah.
let's say, Claude 4.8, which is the recent one, right? Opus 4.8,
Opus
is
4.8. Yeah.
is almost 30x to 60x depending on which model you pick, right?
Yeah.
And the difference in reliability is not more than 10 to 15%.
Yeah.
So one of the real question that an agent developer has is, if assuming you want ROI, is can you have a different framing for how do you pick model, which is in the slide we call it reliability adjusted ROI framing, right?
Yeah.
Which is that I want a certain ROI and can I trade off a bit of a reliability for the ROI for a certain use case?
Yeah.
So this is a genuine requirement because the cost differences are way too high. And there are a lot of agents which will be built for, let's say, regular kind of tasks where the ROI would mean that the model cost has to be much lower.
Yeah.
Customer support, we see that a lot more because the price per minute that the customer is willing to pay for, let's say, an agentic voice is much lower. Let's say for a customer support kind of a task,
Yeah.
right? But there are many such business process automation where you this framing actually works pretty well given you have more choices now.
That is true. Although I have to say, Alibaba Qwen 3.7 is no longer open source. So I
Yeah,
think DeepSeek and Moonshot, Kimi, they'll all end up finding that open source has its limitations, and but they're still much cheaper. Like Qwen, even though it's proprietary, is much cheaper than Opus 4.8.
yeah.
Uh,
Although DeepSeek is still there, if you're not fine tuning, you could
yeah.
potentially use that.
Yeah. Okay. So let's move on because we have a lot of ground to cover. So, what at the highest level, starting from the top, what should be the top few things we should be thinking about?
Yeah. So basically, now that you have plenty of choices on model access, that's no longer the concern. You
Yeah.
can start with the model that works for you.
Hmm.
The next case really is the harness ownership. We've
Yeah.
discussed this that if you're thinking strategically, the biggest piece here is really the harness. So we had the model layer, let's say that's coming from third party, or it comes from OSs, or it comes from your own fine tuning. Doesn't matter.
Hmm.
But basically, that's the choice there. The next piece, which is the harness, and we'll talk about what that has. But that is a strategic piece that you as an enterprise want to own because over a very long term, you want to be able to migrate agents out, swap in, swap out models, all of that, basically. Right.
Yeah.
So you don't want to lose the piece where your migration becomes tedious if that is really
Yeah.
what you want. And harness really sits right in the middle of that discussion. That's one part. The second is, of course, the runtime governance. We still have challenges with governing these agents. Operational reliability is continues to be a concern for a large class of agents, although I do believe that by the end of this year, we will see significant improvement across all categories,
Hmm.
right? But today, if you're building, you still have to worry about how do you get that last mile accuracy? How do you evaluate? How do you further improve these models or these agents if you're building them,
Yeah.
right? So there is an iterative process here, and hopefully we are in the positive loop of that over the next 6 months.
And what do you mean by cognition infrastructure? What does that mean?
This essentially means the four-layer stack that I talked about,
Yeah. Mm-hmm.
which is from the model to the
On.
harness,
Yeah.
all the skills,
Yeah.
tasks,
Context. Yeah.
tools, all of that you have, and then the
Yeah.
interface,
Yeah.
basically,
I
that you
see.
have.
I see. And then enterprise control plane, how should we think about that?
So this is basically think about so we talked about A to E, right? And we're going to get into that slide.
A
But
to
think
agent to environment. We haven't talked too much about it, but yeah, we will come.
we're going to get into that. But
Yeah.
basically, the idea here is that you are going to have in an enterprise many agents deployed.
Yeah.
Now, the control plane that's going to govern and bring these agents together into a multi-agent architecture or agent observability or managing all the agents
Hmm.
together is really what we're talking about. All the pieces which are not really going to do the actual work, but help you observe, monitor.
So a single pane of glass, so I can manage, monitor, update.
That's the control plane.
I see. Okay. Who and is anyone doing that well today? Who's
Yes,
doing
yes,
that?
yes. Oh,
Who?
no, so enterprise control plane is really what all the platform guys will do.
I see.
You can see part of it in many of the leading vendors. For example, in the case of, although I haven't personally used it, but I believe many leading vendors do have the control plane today, or
Okay.
are going after.
Okay, this sounds great. Yeah, because if enterprise will have thousands uh, of agents,
Yeah.
even
So I
more
think recently, if I'm correct, Anthropic announced managed agents. That would
managed. Yeah.
probably fall in that control plane thing,
So
basically.
Anthropic has managed agents. OpenAI has something similar.
Yeah,
AWS Bedrock, Agent Core,
yeah,
Google's Gemini Enterprise. Microsoft has stuff in it. In Salesforce, Agent Force has a control plane for all the agents that are being developed on Salesforce. So I sometimes tell my analyst friends that every keynote we go to is sounds almost the same. So, by the way, we are recording this just as we're going in literally 2 days. I'll be at Snowflake's summit, Snowflake's annual event, and then soon after that, data breaks, and we will most definitely hear more about their agent developments and agent control plane. So with that, so too many choices. So finally we are getting into how is harness engineering different from prompt engineering? So can you walk us through this slide?
yeah. So in very simple terms, the prompt engineering was the era that we left, let's say, maybe mid of last year,
Yeah.
right? But essentially, most of the work was assumed to be, let's say, there will be a minimalist model with a tool calling model. And then all the work was really around how do you really write these prompts,
Yeah.
right? So what ended up happening is people ended up writing very, very long prompts, let's
Yeah.
put it this way. And these prompts were very unstable, flaky, the model changed, the prompt didn't work, so on and so forth. So very hard to manage, and it was basically in some ways dead on arrival, right? There were issues with the context length limitations, all of that as well,
Yes.
right? Now that was an era when we were basically in the co-pilot era, so prompt engineering was probably where we were. Now we are decisively into agentic era, which means multi-turn is by default,
When you
essentially,
say
right?
multi-turn, what does multi-turn mean?
Think about, let's say, if you're doing some coding,
Yeah.
right? You have an idea. Now, what it means is the agent needs to, you have a new feature to implement. The agent needs to first understand what is actually implemented,
Hmm.
where what is the need for the feature. It needs to plan out most of the stuff. Then it needs to go implement, let's say, file by file, like what a normal user would do, and then go test out,
Hmm.
maybe review it, maybe validate it, and then go come back. But essentially, the way you would think about this whole process is there is an idea gets into a planning gets into, let's say, design, implementation, coding, review, rework, so on. So there are many, many steps
Yeah.
before which the agent gives you the output.
Hmm.
Now, when you're building these autonomous systems, the agents can potentially run for hours, essentially. That
Yeah.
is really what our goal is, right? So if you really want to train agents for these kind of tasks, you obviously want the training harness itself to support that first before you can actually use that in practice, right? So this long running execution is one of the key ideas that we have gotten in after we have conquered, let's say, the single turn kind of request, essentially, with these models,
Hmm.
right? So that's basically where it is. Now, as you can imagine, even if, let's say, the agents are good at instruction following, every agent has a different state. The way these models are trained, and we will talk a little bit about RL as well in the post training, is essentially these are simulated environments. But what happens in when you deploy the agent versus when you're actually training them in a controlled environment, they're basically the same. Every agent basically is post trained in the similar fashion, which is that you start with a state, the user wants a certain task to be done, that given the state and the task, the model needs to, or let's say the brain needs to decide what should be the next best action that I need to perform. Let's say I need to call the tool. Or let's say if you're, I just take an example, let's say if you're a recruiter, you're building a recruiter agent. Let's say you've sourced the resume. The next best task could be, hey, let me send an email out to the candidate, let's say, for a interview call, right? So that's the next best action in this case. So once you take the next best action, the next step would be, let's say, the user hasn't responded. In this case, the candidate hasn't responded.
Yeah.
In which case, your next best action should be send a reminder. Versus, let's say, if the candidate has responded, then your next best action is, can I confirm and send him a meeting invite for the interview, let's say, right? So if you think about it simply, all the agents are doing fundamentally the same thing, which is that they start with a given state. There is a task which is assigned to these agents. They understand, plan it out, and then figure out what is the next best action I need to take, and then call that particular tool
Yeah.
or the skill, right? So, skill here is essentially about finding the next best action. Now, as you take more and more actions in a given loop, there are a lot more chances of the agent getting it wrong. And this is where the long running execution reliability comes in. If the agent
So you are, yes, video just hung. So basically, when you have multiple
and
agents,
that's really,
sorry,
yeah,
you were frozen for a second. So please go ahead.
yeah. So what I was saying was, if you are really wanting to take hundreds of actions, the
Yeah.
chances of the agent not achieving the final outcome versus achieving
Yeah.
is where you're going to basically evaluate the agent's reliability,
Yeah.
right? So when we were evaluating the agents before, we were evaluating on a single step.
Hmm.
And now we are basically looking at an agent taking hundreds of steps and then looking at whether we really got the output that we wanted, right?
Yeah.
And in each of these steps, the state keeps changing. For example, agent updated the calendar. That's a state change
Yeah.
with an interview, right? So the next best action, let's say if let's say the candidate doesn't turn up, it would be, let's say, did I even schedule the interview? I need to first check that,
Hmm.
right? And if I did schedule the interview, can I propose the next action, which is that the next date,
Hmm.
let's say,
Hmm.
right? So the state and the actions are intertwined. We call
Hmm.
it tool integrated reasoning, but fundamentally now the models need to be trained on agentic tasks which can run for really long,
Correct. Yeah.
right?
Yeah.
So and then the simulations that the labs currently source
Yeah.
have to come closer to what we want them to do in the real world.
Yeah.
Right. So that's basically what this harness engineering is about. Over
Mhm.
a period of time, we've got many things with this. We have got long running execution. That's one of the capabilities we want. We want stateful cognition, which is about understanding whether they can work with the kind of states, messy states that
Right.
you have in your work environment. Tool orchestration has been there. MCP came from there. Skills are a new piece. We have discussed that before. Sub-agents, you may want to break down the agentic task into many sub-agents. For example, you can have a code review agent or a testing agent versus
Yeah.
a
I,
patch.
so Rajesh,
Yeah,
I can see why this space is getting so fragmented because each thing that you've laid out here has a number of vendors, like the memory system, like Mem0 is one of them. Evaluation, there's like reinforcement learning as a service. There are a whole bunch of companies. Governance, of course, there are tons of companies that are just doing governance. So we are
there's
seeing,
observability as well. Lots of vendors there.
yeah, vulnerability, penetration testing. There's
Yeah,
a lot of stuff going on. So let's move on to the next one, and then we'll keep talking about this. So,
yeah,
okay, so operational reliability. So this is the key. This is the crux, right? We were doing automation. Now we're saying no. So what can you say about this?
yeah. So I think what all of us do feel, and which is probably largely the narrative as well, these models have become fairly, or they feel fairly intelligent. They seem
Yeah,
to always do correct things, or they feel correct, right?
yeah,
But at the same time, when you actually deploy them in production, you tend to have skipped steps. You tend to have sort of variation, silent drift is like we discussed, long reasoning. They most of the time fail, so on and so forth, right? So one of the challenge that one would say when we're building autonomous agents
hmm,
is that intelligence is no longer the concern. The real concern here is how can you really bridge this gap between demo and production, essentially, right? And that continues to be uh, one of the issues with deploying agents. There are many solutions there. We talked about agent lifecycle management, observability, traceability, replace, even post training if the agents do need that, right?
yeah.
The skill engineering, so on and so forth, right? But basically, there are a lot of hooks to reliability. We're still not there, but I expect the
So
models to
when you
continue to
say
improve. Yeah.
silent drift, there's what drift are we talking about here?
We're talking about the drift in terms of reliability over time as the context, the models keep getting their context, they keep updating their context,
Yeah,
memory, all of that. Now, the
yeah,
same task that was working, let's say you tested it to be working, when you actually
yeah,
look at it, let's say a week down, you probably are going to be surprised that you get a different result, essentially,
yeah.
right? There is a slow drift in terms of how these models degrade or these agents degrade in what we had tested them for versus where they end up eventually, right?
Hmm.
So there could be a concept drift as well. By the way, these terms also come from classical ML. Concept drift is also that what we tested these agents for versus what people are actually driving it towards.
Hmm.
There may be a skew in that.
Yeah.
We expected our users to use it for a certain kind class of problem tasks, let's say. But
Yeah.
slowly the task itself is not the same. It has some variation of what you tested for,
Yeah.
what you're not tested for,
Right.
right? So there are various kinds of drifts. It could be a model drift, it could be a
Yeah.
concept
All good.
drift,
Yeah. Yeah.
it could be so all of those basically.
Yeah. Got it. Okay. So this is great. So if we so we've talked so much about harness, and in fact, I was just thinking this slide should have come earlier. But I think we've talked quite a bit about this. But what are the
Yeah,
core capabilities of modern harness?
yeah. So I think we basically in one liner it's everything around the model.
Yeah.
But then if you actually break it down, there are about 8 or 9 capabilities, actually nine today. If you look at all the harnesses that are out there,
Right.
you can pretty much divide the capabilities into 9 different things. I
Yeah.
have added one more, but basically eight, and one from that I believe is important as we get into self-learning and improving agents,
Hmm.
right? For the first few are essentially tools, skills, sub-agents, and workflow orchestration. This pretty much every harness that you see out there has it today, whether you're taking Cloud Code or Codex or deep agents or whatever,
Yeah.
right? Memory and context management is the second piece, which is pretty much consistent across all the harness. Of the way they implement may be different. Some may implement it in a, let's say, just by at the summarization level. Some may implement it in with different strategies. But that's the second one. Long the planning and execution. So, for example, if you looked at many of the agents have something called planning phase.
Hmm. Correct.
So they would actually break the task down into multiple subtasks and then go basically execute each task one by one. And that's basically the fourth point. The verification and eval is a major piece. This is required both when you're actually building an agent and putting it in production, and then also at a production level where you want to evaluate when the agent starts drifting, whether before giving the final output to the user,
Hmm.
right? So verification and evaluation is pretty important. This includes that's the one, multi-model abstraction and routing. Many of the agents have this where you don't want to work just with one model, you want to work with many
Yep.
models. For example, you might use a model for fallback, you might use a model maybe for a set of sub agents or set of tasks, so on and so forth, and a
Yep.
different model for a different task, right? So multi-model abstraction and routing is another one. Observability, replay, and governance. This is obviously you want to trace down every piece of what actions were taken, what intents were given by the user, so on and so forth. That's that piece. And feedback and the continuous learning loop is a newer piece, but essentially the agents often update their memory about what do they know about these users,
Yeah.
the user who's asking this question. Did he give me a feedback that I need to remember for long term so that I don't repeat the mistakes, so on and so forth, right? That's basically the feedback loop.
Got it.
And there is some agents have a minimal, agents have extensive version of this, and this piece will further evolve essentially. But these are the sort of 8 capabilities. The first one I didn't talk about, but that's mostly coming from how do we train these agents? Uh, the environment and runtime control is roughly around RL environments where we want to be able to trace down these agents step by step before deploying so that we exactly know what these agents are doing.
Got it.
Right. So
And I
those are the
think,
9 capabilities that
yeah.
you expect.
So the first one also brings us to this agent to environment. What is A to E? And is this something new? Who came up with this term? Mm,
So yeah, this is something that we've been working on, and you won't find reference to this term on the internet, but we've just got the website up, and the link is down there on the slide.
I see.
We hope that we will put out the Python SDK over next 3 to 4 days
Okay.
for people to try it out themselves. But the idea is very simple, and it stems from all what we've discussed, which is that we at some point want enterprises to own their harness. that gives them a lot of benefits, right? So the idea stems from a very simple thing. Could we have had, given that we know that these are the 8, 9 capabilities that almost every harness has, could we have had an interface which is standardized enough, almost like MCP, but MCP has a much narrow scope,
Hmm.
which is how do agents interact with the world around them,
Hmm.
right? And the world
Yeah.
around here, we mean the harness.
Yeah.
And we've included 9 core capabilities. This includes the training environments, the tools, the memories, the skills, the verifiers, and learning systems that we discussed before.
Yeah.
But the idea is if you can separate the concerns,
Hmm.
uh, separation of concerns architecturally, then the ownership of the harness can be detached from the model vendor,
Hmm. I,
right? So A to A in if you basically go back in time, we had POSIX, which was basically the interface between the kernel and the applications that we're building in the user plane. Right.
yeah.
So our expectation is that eventually A to A will, if it becomes popular, would be the POSIX layer for agents and the runtime environment that they operate in.
So could I have a runtime governance company adhere to A2E protocol and then just be plug and play?
Yes, you can, and that's really what we're aiming for, which is that you, let's say if you're an enterprise, right,
Yeah.
the agent becomes much simpler. It basically is modeled with, let's say, a recursive or a React loop
Yeah.
around it,
Yeah.
and it interfaces via A to A client into the harness, which is the environment that you have, which hosts all your tools, all your skills, all your runtime capabilities, memory, all of that,
Right.
right? So let's say if you were to switch out, let's say the agent model and bring another one, the
Yeah.
harness is still what you built. Most of it you're building is on top of the harness. So harness and what you build on the top still stays with you, essentially.
I see.
And that's really what this A2A does, basically,
So
right?
basically, what you're saying is, you talked about the four layers. So the model, harness, skills and context, and the interface. So you're making each of these interoperable. You can, so
Not each
you
of this,
did,
but if you look at the model,
I see. Yeah.
which is an agent, let's think of model as an agent,
Yeah.
and then the harness, which is on top of it.
Right. Yeah.
These two are talking to each other through a standard interface.
Right.
The skills that you built on top of the harness were anyway yours, but now you also own the harness, essentially,
I see. Got it.
right? So let's say you're swapping out this agent
Yeah.
layer with the
Yeah.
model,
Yeah.
all the other stack remains the same, and you can just plug in another agent, essentially. Like in many, a lot of people said MCP is the USB for tools. This is more of a USB for the agent itself. Uh,
For
in
agents. I
Right? And
see.
here you have to consider model as an agent. The
Yeah.
definition is very stark because, uh, I mean, people define it differently, but a model with a tool calling is roughly an agent here.
Hmm. So I could use LangChain to create my model or N8 or whatever
No, no,
is a flavor of the
no.
day.
Those are different.
Yeah.
This one is more about, let's say, if you let's take an example, right? Let's say you're building a customer support agent,
Yeah. Okay.
right? Now, which means that you're using four tools, you've built 3, 4 skills for this
Yeah.
agent that
Mhm.
this agent needs to follow.
Hmm.
Now, today, what you're doing is you're basically tying this to either LangChain or Deep Agent or whatever,
Yeah.
or let's say to Cloud Code or Codex,
Yeah. Yeah.
whichever is the harness you're using, and
Yeah.
then building on top. Now,
Yeah.
what this does is it basically says, hey, I am building all this in an environment which is A2E compliant,
Hmm.
right? So you've taken the A2E SDK, you build everything on top of it, this
Hmm.
environment,
Hmm.
which means that if you just import an A2E client and connect any model to it,
I see. Got
the
it. Got
agent
it.
becomes much more simpler,
Right.
right? So you're not tied to any library itself. You
Right.
own the whole piece because it just works. It's standard interface, just like we said, POSIX. If you build an application with a POSIX compliant file system
Yeah.
call, it doesn't matter what is
Yeah.
the disk under the hood, basically.
Right. Got it. Okay. So we've got a lot of core primitives here. Uh,
Yeah.
Instead of going through each one because we're getting close to the
Yeah,
end.
yeah. No, I think we've already covered this, but
Yeah,
and then the link also has most of it with
I see.
examples. So
Okay,
if people are interested, they can go through that.
got it. So, I think we've covered some of this too, but do you
Yeah.
want to recap?
I want to add a couple more points.
Yeah.
One of the key things that I believe will happen over time beyond standardization, portability, all of that, which is important for today,
Hmm.
is there are, and this is too important because all the data that you generate is owned by you as an enterprise, whether it's
Yeah.
trajectories, feedbacks, evaluation, all of that.
Hmm.
And then you could use them for post-training your own agent, for example, in the
Hmm.
future,
Hmm.
right? And this is going to be important because there's already a lot of discussion around self-learning and continuously improving agents. And in an environment where the agents have to continuously improve, let's say over the next 1 to 3 years, you owning many of these pieces are going to be super important. Now, one of the capabilities that we've added to A2A is also in RL environments where there's a certain way we train models today, and the A2A also makes those primitives standard, essentially.
Got it.
Uh, so you could basically switch an agent between training and inference mode, and when you're switching it to a training mode, it would basically use the environment primitive, which are focused on training.
Like GPUs versus CPUs.
That and the trajectory creation and taking the trajectories and then triggering the next run, updating the model's weight
Got it.
so that the next time you put it in production, it will be the new model, essentially.
Okay. So this sounds very promising. And so we've got two more slides. So let's switch gears. Next 1 to 3 years, what should we be looking at?
So first thing, uh, agents are the new applications. That's a first thought, right? So we're going to have thousands of agents executing business processes across enterprises. We're not there today, but this is obviously going to race, and every enterprise would have agents
Yeah.
running a business process.
Yeah.
That's the first one. Now, how do we get there? Uh, the first part is, of course, the models and the OSS models all will continue to improve over across variety of more tasks than what we see today, which is primarily coding and some of the general tasks. But they continue to improve, and you get to, let's say, something like 80% of what you want
Hmm.
across majority of the tasks that you have. At that point, the next question would be, how do you really jump and get what you want, which is, let's say, 99 to 100%, right? So what we're going to also see is this whole idea of self-improving agents, continuously learning from execution, maybe updating the skills, maybe creating new skills, maybe updating the memory, reusing it in the context, or maybe even updating the weights of the model, right? In real time. Or let's say when you're sleeping, when the agent is it's actually training when it's not working, right? So you will see a lot of self-improving agents. That's the second piece. Verifier first execution, this is important. Today, largely verifiers are thought as an eval mode thing, which is before I put it to production.
Hmm.
But as tokens and the inferences become cheaper, you want to evaluate model on every single execution, every single step that it has taken, right? So your execution needs to basically incorporate and think verification as a standard workflow primitive.
Yeah.
That's a third thing that we will see
You need that for self-improving agents anyway, right? Otherwise,
as well. Yeah,
yeah,
as well. Yeah.
yeah.
So those are the four, and of course the thousands of them running in concert. I think that's going to be the overarching picture, which is
So
multi-agent
these
orchestration, so on and so
these things that we have here on the list. So we're already doing this, right? But how will it change in 1 to 3 years?
forth. We are actually not doing this because most have not made it to production. Even the coding agents, you have a human in the loop, for example, today,
Yeah,
most of the time.
yeah,
Although they can go further, but you cannot leave them alone in some
right.
ways.
Yeah.
Right. So the true autonomous agents, even though we call them agents, is still a dream at this
Hmm.
point.
Hmm. I see. Okay. So. Because when I look at this list, so if I go back, I know we have a bunch of companies doing observability compliance. We have a bunch of companies that are doing orchestration, but they're still
Yeah.
very early in the journey.
Yeah.
So, uh, so and will
Yeah, but I think all of this from an enterprise standpoint, you're going to have all of them basically. But
yeah,
how the bigger challenge is really what the term stack, right? How does all that fit into one seamless story?
yeah, yeah,
Is really where the challenge is going to be.
yeah. So wrapping this up, what are some key takeaways?
Yeah. So first is we've already made this move that we don't want just automation agents.
Yeah.
Um, what we started the year with, we want intelligent systems.
Hmm.
And the key thought here from enterprise standpoint is you want to have these intelligent systems without vendor lock
Hmm.
because you've lived this before and you've had a mess of infrastructure and very little value. So you want to have the infrastructure level ownership and strategic thinking at the point of designing what you really need, basically. So that's the first thought. And this has to account for the goals that you're going after, which is that agents are going to operate continuously and autonomously over next 1 to 3 years. That's first goal that you want to keep in mind.
Yeah.
Environments and harness are the execution substrats,
Hmm.
and they're going to become very crucial when you look at how do you source them or how do you really build them, or if you're sourcing them, are they compliant with a certain interface where they are swappable?
Yeah.
Essentially, if you swap the model, will they work?
Yeah.
Verifiers, we've discussed that already. The feedback loops are going to be critical. So how do you track all the memory that the agents generate? How do you annotate them? How do you improve them? And how do you then use it for your next improvement?
Yeah.
That's going to be important for the last mile delivery. Right. So in summary, you basically win if you have a better harness, better governance system, better runtime infrastructure, and of course, all that ends up being a good operational system, essentially.
Yeah. So I feel we need to have another episode where we are talking maybe 6 months from now as to where are we in this journey and how things are changing. Actually, 6 months sounds like 6 years in AI.
Yeah.
Uh,
Yeah.
but the speed at which things are changing is just so rapid. So I want to thank you so much for coming on this, and thanks everyone. We will talk again. And Rajesh, really appreciate your time.
Thanks, Sanjeev. Happy to be back here again, and it was wonderful talking to you.
Thank you. See you. Bye.